Hey, Revision General here, back with another one. Today we're doing index laws, what they are, how they work, and easy, medium and hard mode questions as usual. This is a grade 4 topic, so it's going to be on both the foundation and on the higher tier paper. What does this mean? Well, on higher tier, you'll need to apply the knowledge of index laws to an external question. But for foundation, you will just need to use index laws in a question to get an answer. Usually higher tier questions like that will give you more marks. Now, without further ado, let's get going, shall we? Right, let's start with easy mode, shall we? So firstly with index laws, we've got a scenario where you've got w to the power of 4 times by w to the power of 7. Now, under conventional timesing, you'll think that you'll just do 4 times 7 to the powers to get a w to the power of 28. However, with index laws, it's actually different. What you do, when you times two variables or two numbers which have powers together, you times the w's, but as we have one w basically because there's no one written, however it is a single w, we do 1 times 1 here, but let's just add these w's for add these numbers for your reference. We do 1w times 1w, which is obviously 1w, but with the powers we add them. So what we get is w to the power of 11. Now, using this kind of logic, when you've got s to the power of 23 divided by s to the power of 11, you'll think that you divide 23 by 11, which gives you approximately what, 0.09 recurring or something along those lines. However, we don't do that. Again, instead of dividing, we take away the powers. Now, obviously, 1s divided by 1s, so you get just s to the power of 23 minus 11 is 12. So you get s to the power of 12. Now, with question 3, with y to the power of 4 in brackets, and then outside the brackets you've got a power to 5. This is a power on power law. Now, power on power, we do indeed times. So therefore, we do y to the power of 4 times that by 5, so 4 times 5 is 20, so your answer is y to the power of 20. Quite simple, right? Now we get a little bit harder. We've got 13x to the power of 12 times 13x to the power of 21. Now we have a coefficient in front of the s. So therefore, we have something times with. So we have 13x times 13x, that's 169 because of 13 squared x. Then with the timesing powers, we add, so then you do 12 plus 21 is 33. So you got 169x to the power of 33. Now, this is a fun one. You've got question 5 here, 15 to the power of 0. Now anything, no matter what number it is, even if it's 0, even if it's like -1 or 1,000, anything to the power of 0 will always be 1. So 15 to the power of 0 is 1. Now, question 6. You've got 2 to the power of -2. We have a first negative power. Now you can do this in multiple ways, to be honest. You can either treat it as 2 to the power of 2, then we deal with the minus, or we can deal with the minus first and then do the second power. I personally believe it's better to do the negative first so you don't get mixed up, but it really does depend on you. So you've got 2 to the power of -2, so let's deal with the 2 first. So 2 squared is 4, so you've got 4 to the power of -1 basically, don't we? Because anything to the power of 1 is the same as we already have, so we have a -1 on that, so we have 4 to the power of -1. Now anything to the power of -1 is a reciprocal. What do I mean by reciprocal? Let me just write this down. Reciprocal. So what does this mean? This means if you got 4 and you want a reciprocal of 4, you do a quarter. If you have the number 100 and you want a reciprocal of that 100, you get 1 over 100 and 100th. Now, if you want the reciprocal of 1 over 100, you just get 100 back. And to the power of -1, is a way for mathematicians to say, I want the reciprocal of that number. So the reciprocal of 4 here, as I already said, is a quarter. This is very simple compared to simple and compound interest of episode 1. This is blatantly easy. It's an easy few marks in your GCSE exam, which could be the difference between your 4 and your 5, or to be honest, even in higher tier, it could be a difference between like a 5 or a 6 or a 7 or an 8, depending how good you are with the higher level topics. And the fact is, just for conventional wisdom's sake, if you are a higher level student, don't forget the easy stuff, because on the exam you'll focus on, let's say, circle geometry, for example, which is like grade 7, grade 8 skill, but then you forget the easy stuff, and then you just lose marks on silly things like, oh, what did a negative power do again? I forgot. A reciprocal. So I even say for the higher end student, still watch these kind of videos about the easy stuff, just to secure that knowledge in your head. Now let's get on to medium mode, and let's do some more difficult questions. Now, here we've got medium mode, a little bit more difficult styles of questions, however not too difficult in my opinion. I could see personally these at the very beginning of a higher tier paper, and if the examiners want, this will be round in the middle section of a foundation tier paper. Now, let's get started. Question 1, p to the power of a times p to the power of 7 equals p to the power of 2100. Obviously, as I said in the previous video, large numbers are made to throw you off. Now, you need to find the value of a, of course. What this is trying to make you do is to apply laws of indices. So what you need to do, I think you've figured it out, that you need to take this p to the power of 7 to the right hand side to divide p to the power of 2100 by p to the power of 7. So let's do that. So p to the power of 2100 divided by p to the power of 7. Remember that dividing with index laws is obviously taking away these powers. So your answer will be p, because obviously 1 divided by 1 is 1. So you've got p to the power of 2093. Am I correct? I am indeed correct. So that's your 2 marks. Look how simple it is. So where the mark scheme gives you marks is by converting your times by p to the power of 7 to divide by p to the power of 7, and then doing the physical calculation after that point. Now, next thing is question 2. So here we've got in your brackets, you've got 5 to the power of 3 times by 25 to the power of 3 divided by 5 to the power of 2 equals 5 to the power of x. Now, why are there so many 5s? So you get mixed up. That's what the examiner does. They want to get into your head so you do a mistake. So how do we do this? We've got 3 marks because of the increased difficulty of this question. I'll even say this could be bordering a hard mode question. Therefore, it would be in the middle, potentially, of it will be in like the 40% range of a higher tier paper. So first, obviously with your bid mass, your order of operations, we do everything in the brackets first. So let's write this out. 5 to the power of 3 times by 25 to the power of 3. So remember, 25 is just 5 squared. So we can just rewrite this. Let's just put brackets to make it more obvious. So 5 to the power of 3 times by 5 to the power of 2, brackets, 5 to the power of 3. To the power of 3, sorry. So what we have is 5 to the power of 2, because that's 25. Then powering all of that is the third power here. So what we do here, power on power law, we get we times 2 by 3, so that's 6. So we get 5 to the power of 3 times by 5 to the power of 6, and then we got the second rule. Second index rule is just adding these powers because we times them together, giving us 5 to the power of 9. Therefore, as we've evaluated that, we can put it here underneath here. So 5 to the power of 9 divided by, here, 5 to the power of 2. We just take away these powers, as we did with question 1, which gives us 5 to the power of 7. So 7, as we've got 5 to the power of x here, equals x. Quite simple. If you know what you're doing, I believe that most of maths is simple. If you've learnt what you're doing and you know it. Half the battle with maths is about seeing it, not actually doing the maths itself. So what is the value of, question 3 here, what is the value of the reciprocal of 99? Now from easy mode we know that reciprocal is converting this to 1 divided by whatever this value is, here 99, so it's 1 over 99, quite simple. Here the examiner just wants to see if we know what the word reciprocal means. It could be what is the value of 99 to the power of minus 1, which obviously is the same as reciprocal, so it will be the same answer. So with question 3b now, you've got 49, I'll just write this bigger for you, 49 to the power of minus 1 over 2. Like with easy mode, we just need to now use both our to the power of a half skills and the negative value. So negative value is reciprocal, as I've just said, so it's 1 over 49, and then we know to the power of a half. Now this is another skill. So a power of a half is the same as rooting, because think about it, if it was to the power of 2, that would be squaring, wouldn't it? And the reciprocal of 2 is a half, so it's kind of like its inverse. So the inverse of squaring is rooting. So if you have a half, you're rooting that number. If it's a third, you're cube rooting it. It's about halving it will be square rooting in that scenario. A quarter will be doing the fourth root of it. Now, if you're doing the square root of 49, that would just be 7. So the answer is 1 over 7. Now, question 4, this is a nice one again, using the whole thing with power on power laws. Because you've got 25 again to the power of 2. Now look at that, you've got 25 again. So that shows that the examiner mostly favours simple square numbers. So they will potentially go 16 or 25 or 64 to see A, if you know your square numbers, and B, if can you apply that knowledge with index laws. So here what we do again, we convert 25 to 5, so 5 to the power of 2, again to the power of 2, so this here, so power on power law, that's 2 times 2, which is 4, which equals 5 to the x. So therefore we can see from this relationship here that x must equal 4. These are very simple questions if you know what you're doing. Now, let's get on to hard mode and see what the hardest difficulty gives us. Now here's hard mode. This is the most kind of difficult question you're going to get on this topic in the GCSE paper, in my opinion. Now, this will potentially, in my opinion, be in the middle of a higher tier paper and potentially near the latter third of a foundation tier paper. Now, let's get stuck in, shall we? So question 1 is simplify this expression. So when you get this kind of more complex expression, I'll personally say, put it in a fraction format. So 12x to the power of 2, y to the power of 8, divided by 8, obviously put them in brackets, it's just easier in terms of order of operations, it's a habit I've gotten into, and it causes the limitation of mistakes during being under pressure and under time conditions, which you will in fact be in a GCSE exam. So it's just a good habit to get into. Now continuing, so that's 8xy to the power of 4. Now, first of all, you see instantly that obviously 12 and 8 are even numbers, so you can simplify them. But I would actually heed on that, because you can't simplify 12 into 8 fully, you'll get a decimal. So let's actually do the ones which you can fully simplify, like your x squared and your x. Obviously, you can take that x out and you can take one x out of x squared, giving you, again, your brackets, 12x y to the 8, 8y to the 4. Then we can do that again with the y's, so we take y to the power of 4 out of y to the power of 8, so we just do 8 take away 4, you get 4, so therefore we've taken them out from the denominator, or your lower section of the fraction, so you've got 8, and then you've got 12x, y to the 4 of course. So therefore, from this point, let's put an arrow here, again, do your structure. It's good to always point the examiner where you're writing the next part of your equation or your process of simplification in this scenario. So then we can simplify this because we know that both of these are divisible by 4. So we can just do 3xy to the power of 4 in brackets over, of course, 2. And that's your answer. You could also write it, of course, in the format of 3 over 2 times x. You see the difference between timesing and adding a variable x. It's just good because the examiner will get maybe a bad quality image of your GCSE exam. Therefore, they may not see the difference between a times and an x if you don't have good handwriting. I'm talking here, of course, from experience. So it's good to just have a different style of writing x and a times symbol. And then you can just put times x, y to the 4. Now, I'd personally recommend the prior, just because in maths it's a better format of just leaving your answer in. You don't have two sections, your 3 over 2 part and your x, y to the 4 part. I'd personally recommend this. Now, going to question 2, r to the power of 25 times by r squared equals r to the power of 9 times r to the power of x. This is quite simple if you know your index laws. So of course you can add 25 and 2 because obviously they're being times together. So r to the power of 25 times r to the power of 2 equals r to the power of 27 and then you've got obviously your r to the power of 27 now on your left hand side of this equation because you've simplified this part as if there's brackets here, and then you got r to the power of 9 times r to the power of x. So then obviously you can take r to the power of 9 to the other side. Instead of timesing by r to the power of 9, we're dividing by r to the power of 9. So you have here, I'll write it here, r to the power of 27 divided by r to the power of 9. So what we get from this, obviously, is take away 27 from 9, we get 18. So your answer is, we get a result of r to the power of 18, but we need to find the value of x. Remember to always read the question what they want, even though you simplify it, you'll be like, what do I need to do? Here, find the value of x. So because we're trying to find r to the power of x, we know the power will be x, which is 18, so 18 equals x. Lovely. Now let's go and get on to question 3, shall we? So here we've got 3 to the power of 9 times by 3 to the power of minus 1/2. I've written it in this format because we can treat this, because we know we need to add these two because we're timesing and we know index laws. We can do it like fractions, can't we? So we can just convert 9 to 9 over 1, and then we can just add it to negative 1/2. As such, because we're just adding these powers, obviously because it's a minus, we're actually taking away because a plus and a minus is a minus, and then we can convert 9 over 1 to 18 over 2, just have the same denominator, so we can just do this. So we can do 18 over 2, take away 1/2, which is 17 over 2, and then we can just leave it as 3 to the power of 17 over 2, or in fact, we can leave it as 3 in a decimal format, of course, 3 to the power of 8.5. And this is how you do hard mode. You see, in terms of a step-by-step basis, it's not that difficult. It's just understanding what you need to do and in what circumstance. In terms of other hard mode questions, you'll get maybe a more application-based question. So it will say like, Jimmy has this many chickens or whatever, and you just need to create this kind of expression and then simplify it. That is possible. I'll see that more on an A-level basis, I think, in terms of these kind of index laws. But to be honest, you never know if you're going to get a lower tier index laws question, which is actually application based. That could in fact happen, to be honest. But mostly I see them in this kind of format if they're kind of higher tier. Now, let's go to the outro and my kind of final thoughts regarding this overall, and maybe some final words of wisdom before I go. Firstly, from all the 3 difficulty levels that are showcased today, any of those questions can show the foundation and the higher tier paper. But don't worry, I'll reassure you with this, that when you get more proficient at identifying and understanding these laws, they'll become as if second nature to you. Therefore, you can do them quickly and easily, reassuring you against all the more difficult questions which will be present in your paper. Now, next episode will be Pythagoras and how to use his theorem to solve difficult questions. Now, like, subscribe, do what you need to do, and I'll see you in the next one.